Hi, good afternoon, good evening, or good morning, depending on where you are in the world. Welcome to the SETI Institute. I'm Pamela Harman, the Director of Education. It's my pleasure to have you here with us again today on Facebook. We're going to look at part of our visitor experience here at the Institute, talk about the science behind it, and perhaps we're going to have time to talk about the SETI Institute science research in the solar system. So over here, I'd like to just take a quick look at these models of planets in our solar system and the moons. And these planets are beautiful. They are to scale, and the moons are also to the same scale. These models were developed and manufactured and given to us by AstroReality. Our two guests this afternoon are from AstroReality. And I'd like to introduce Joanne and JR.
Hello.
And
hi, everyone.
Hi, and thank them for these great AstroReality moons and planets. And not only are they beautiful scale models, but they have augmented reality data applications and functions. So I'm going to turn it over to them. Please tell us all a little bit more about yourself, about how the models came to be, what AstroReality is, and what's the science behind it, and how we can use it for science.
Hi, everyone. I'm Joanne from AstroReality. I'm the co-founder of AstroReality. And JR?
I'm a SETI scientist as well as science advisor for AstroReality, trying to make sure that all the data that we're creating with the scientists with this institute is being used to be able to communicate the research we're doing and the science to everyone in the public.
So what AstroReality makes are those 3D printed originally, and then we craft and then we made a mod and make them a planetary models. So we have some products under AstroReality. One is the moon model, lunar over here, and also the Earth model over here, and our lovely Mars model. And all those models and products that we make are AR driven and AR enabled. We also have some notebooks over here, Mars notebook as well as the lunar notebook. And then again, all the products we make are augmented reality. What we are trying to do is we want to bring space exploration, that kind of topic, for our consumer and the general public.
Yeah, like as scientists, we're working on such amazing things. The surface of Mars, the oceans of Europa, all these things that are incredibly exciting for the people of the world to understand and scientists to explore, but they can be a little hard to kind of relate to. So one of the goals of these models is putting these places into your hands. Now you can hold the moon and explore the same mare in your hands that the Apollo astronauts walked on. These places that were once just points of light in the night sky are now worlds that you can hold on to, feel with your hands, and explore with augmented reality. So it's really about using technologies to put these places into people's hands.
And today we want to introduce the two-scale model set for SETI Institute. This is the first set of models that we make as solar system models for SETI Institute.
So we're hoping that more museums and other educational places where people want to see the great detail of the models, but in scale with each other. Like you can see how how small Earth and Mercury and Venus are compared to the gas giants. And there's nothing like seeing these worlds in context of how they are to show how small we are compared to the rest of the solar system.
For those of us who don't know exactly what augmented reality is, can you explain augmented reality to us?
Definitely. So augmented reality is basically an overlay display over a physical object or physical product that we make. For example, we have this application that you can install in your device, in your mobile devices, and point your device to the model itself, and there is an overlay information basically popping on the physical product.
So right now, this one puts locations. So if you have a normal printed globe, it'll have all the names of cities located on countries, and so we can add those layers digitally. So that doesn't affect the actual model, but it becomes as a digital layer. And now, whenever a globe is printed, it's out of date the moment that it happens because countries will change names, rivers will move, all those things will happen on some period. Where now digitally we can always keep it updated. And on top of that, we can show things that most maps can't. So now this looks on the inside of the Earth. So we can open it up and look at the core, the mantle, and it's still tracking to this actual globe in your hands because I'm moving it now. And so this way we can pair all the digital data sets that NASA has created, that the SETI scientists are developing for Earth, for the Moon, for other places, and take the best data, the always updated data, and put it on a physical model that you can feel the features of.
So for augmented reality, the capability of how it can display is not only just information, but also really, like JR said, you can see inside of Earth. You can also see, for example, for the Earth model, you are able to see the time change. And for this Lunar Pro, the Moon model, you can see a lot of landmarks and human missions on the Moon, as well as this color elevation data that we will be able to visualize data in a way that we can understand and approach. We have created several experiences. For example, this Apollo 11 experience that you can see this 3D animated video on top of this Moon model. It's basically simulating the Apollo 11 landing mission, and you can basically look at it in a 3D environment.
Well, let's give some thumbs up and hearts for that wonderful explanation about what augmented reality is and how we can use it. So what's what data sets? How do you make this happen?
Yeah, so luckily, like NASA and the NOAA and all these government organizations have a whole fleet of satellites, always taking images of the Moon as well as so many on Earth. We have just constant data coming down, and so what we're able to do is take like this amazing public resource of government data and put it into this 3D environment, and that allows people to experience it. Like if there's many different portals and NASA data sites where anyone can go get this data, even just like taken a few minutes ago in some databases. But it can be sometimes hard to really understand what it means, how does it relate with the story of Earth. So that's the beauty of augmented reality, and especially having like globes that you can hold, is it takes all this data that we're collecting and puts into context. You can see how clouds are going over your home while feeling the mountains that you're having in your area. You can see inside the planet animations, that things that we can't actually ever see by traveling, because they're deep in the Earth. We can do the modeling, take all the geophysical data and turn that into animations and information that people can now see these things that they could never see in real life. So yeah, a mix of just data that's out there and animations and things done to kind of share these wonders of the world.
Sounds like this would be really useful in education and outreach. Do you have plans to put this in place in education outreach facilities?
Yeah, yes, we created the Moon model, Lunar Pro, originally. We are a team of space enthusiasts. We wanted to create this model in order to have our consumer or our audiences to be able to be close to space exploration theme. And then we created Earth model. Then it shows a lot of data and a lot of content on top of Earth. Then a lot of educational institutes and schools come to AstroReality and say, we really want to have those models in the classroom to be able to have our next generation to interact and then to learn Earth science in a very immersive way. So AstroReality is dedicate a lot of our resource as well as our part of the business trying to approach to education. We really want to have those models in the classrooms and schools, and for our next generation to learn Earth science in a very different way. We are working with education partners that are going to have those models in a lot of schools and, let's say, libraries and a lot of places.
As a scientist, a lot of my day is spent researching. I look at volcanoes on Mars and a lot of field work on Earth, and it's always great to actually communicate that. Scientists doing science is a good thing for humanity, but it really becomes valuable when we can communicate it to students who want to be the next generation, to voters who need to keep the NASA appreciated. So being able to communicate all these work that we're doing to the public who's actually supporting it is such an important thing. So these models as artifacts that we can take to schools, take to the public, and say, hey, like this is where we're working, this is a real place that exists, and this is what we're learning about it. It's such a great educational tool for taking real science and delivering it to the people who care about it.
Yeah, thank you. We always like to say that science isn't done until it's shared. Definitely. And this is just a very powerful way of sharing that science. my work in education, I'm really excited about, the opportunity to get this curriculum developed and see how it could be used in classrooms. I just think it's a marvelous opportunity and a great idea. If you have questions about Mars, because JR just reminded us he's a Mars scientist, be sure and submit those questions. What else? Do you have something you would tell us about the Earth model there, or Mars?
Yeah, so I guess just in generally the fact that SETI scientists work all throughout the solar system. We work places like I work in Mili Patera of Mars. It's a caldera that's my favorite. We have people having these models here. Is it turns all these names into real places. We can say, oh, like I study a couple different rover sites on Mars. I do field work in Antarctica and Iceland on Earth. The people who are drilling undersea in Antarctica, it's irrelevant to work they want to do on Europa. Like, you see the fact that these are real places out there, and it gives this kind of geographic feel of how big our solar system is, and takes us out of the everyday kind of Earth-centric view we have. And so I think that kind of perspective is such a powerful thing of having these models in front. And I think, especially as visitors come to this experience, being able to show how SETI is spreading its research throughout the solar system is such a powerful reminder of the important work that we're doing.
Thank you. And Joanne, are you a planetary scientist? How did you get interested in the solar system?
Well, I'm not a planetary scientist, but I am a space enthusiast. So what I try to do is to bring my passion and enthusiasm into space exploration, as well as to deliver this passion to our consumer and target audiences. I would say we want to bring space exploration, and we want to bring this type of science behind this closer to general public, to us, to our daily life. Is not only for us, but also, as I mentioned, for our next generation to learn science in a very different way, in a way that we've never learned, in a way that we've never experienced. We really want this type of immersive learning and have every single model in every single school, hopefully, in United States.
And that's really exciting part of this technology. It's augmented reality. It's like so much potential. We're just beginning to really explore it. Like many people out there may have played Pokemon Go, which is like one of the first widespread use of AR in entertainment and the first app that people had to experience it. And that allows you to take this like fun fictional world and put it upon your own. And that kind of combination of digital and real is such a powerful thing as mobile devices, as wearables, as all this technology gets better that makes that experience more powerful. We will really be able to experience our world in a new way as this technology matures. So on top of the educational uses, AstroReality is partnering with SETI to create tools for explorers. We're working on apps to go explore field sites. So when SETI scientists are studying Mars analogs out in the deserts of Earth, they can use their augmented reality to understand what data has already been done, what are the places they want to explore, what rocks they want to sample. Those same tools will hopefully be hooked into the visors of future explorers on Mars, so they can immediately know which rock they want to pick up, which places they shouldn't go because it's too steep when they're driving. All of these kind of really understanding the real world with digital data is such a high potential growth for future exploration and making that life just a lot more robust.
So AstroReality is trying to help and support, not in a way that for consumers to make those products accessible for consumers, but also to support scientists as well as a lot of science research if possible. For example, to make 2-scale models in a way to experience the solar system models, but also to make augmented reality experience for science research or science projects.
So here at the Institute, we do have, in addition to JR, several scientists who study Mars and other objects in our solar system. I mean, we've heard Natalie Cabral talk about her work. Lori Fenton studies alien features on Mars. We've got scientists who study extremophiles. John Marshall's done Mars research and engineering and instrumentation. And I think about Margaret and her work in planetary protection, but the astronauts, so the Mars and the Moon, so NASA says we're going to the Moon soon, and then to Mars, not as soon, but the new administrator is really following the executive order and the executive policies to get us to the moon. And so I hadn't even thought about how AstroReality could help astronauts going to the moon, the Marsnauts going to Mars, and really with enough data, like you said, make that rock selection. And
so like if with the Apollo mission, they were such a focused process. So each astronaut on the surface of the moon, when they were doing their selection, they had a whole team of geologists and scientists, and engineers in their ear talking, oh, I want this rock. Time delay, you don't have that many people working on it. So being able to like digitize that information, being able to already put that in will just really help this robotic human interaction as the future of exploration.
Yeah, so I'll see if we have any questions from our viewers. Give a thumbs up and hearts for Joanne and JR again. I'm looking at the Mars model, and I see that you have plate text. You have the
plate boundaries. Yep.
Yeah, the plate boundaries, and it reminds me that Friedman Freund does a lot of earthquake research, trying to come up with a system that can predict earthquakes based on the charge in rock formations due to the pressure, and you could probably build those data sets into the model and explore that. So I see that as serving humankind, and preventing as much loss as possible from earthquakes.
Yeah, like as a scientist, I spend a lot of time on Google Earth. It's one of the best ways to visualize data, but a lot of my work's done on flat maps or on screens, and just being able to take the real data and put it on a globe really helps you visualize it. So for earthquake understanding just how the spherical geometry works, I think provides a lot of understanding, and getting that research put into this data set. So like right now, ArcMap is the way that most scientists put data geographically. But building this out for the future, allowing scientists to work in augmented reality, put their data in to actually see connections that you can't see on a flat map. Such a powerful thing for taking that science to a bit more realistic level.
Well, and on ASCO, Pascal Lee works to plan pathways and routes for rovers on Mars, and it would be much more powerful to do it in a 3D environment than that flat map environment. Same thought process, just
rovers, as well as like working with orbiters, like figuring out how you want to orbit the moon, those kind of constellations of satellites, so you can get rover and orbital information working together. Seeing that on these kind of models in augmented reality is such a more powerful way to understand the dynamics of how those are connected. So I guess we have a few questions. So one question from Glenn came, what's inside the gas giants? So as the name says, a lot of it's gas. So, Jupiter is kind of a small star, or a much smaller version of what the star is. So just as a star is made of hydrogen and helium, most of Jupiter is hydrogen and helium in the atmosphere. At the very center of it, things get a little weird. A lot of pressure and stuff that we're not used to having is happening there, causing like metallic hydrogen, where the electrons are stripped off the hydrogen, causing like weird substances that we don't have on Earth. And below that, we believe that there's the same kind of rocks and materials that make up the other planets at the core of it. So it's a rocky iron core like many other planets, surrounded by a much greater atmosphere of gases, and most of it's hydrogen and helium. And we're open to more questions if people have about Mars, about AR, about any of that. Apparently people here are listening from Italy, Dallas, Texas, San Antonio, Texas, Northern California, where we are, Sacramento, Scotland, Manitoba, Canada, Norway, Eastern Canada, Istanbul, Bracknell, UK, Colombia, a few people from Australia and Bolivia, Kentucky, India, Ireland, London, Belgium, Norway, Slovenia. Wow, it's really hitting around the world.
Yeah, around the world.
Netherlands and Christchurch, New Zealand. So thank you all for calling in or watching in from all around the world, and hopefully in a few years people will be coming in from all over the solar system to watch this sort of information.
So do you have data sets for the gas giants in development? I know I've been playing with Mars and the Moon and Earth, but
so we have another book for Jupiter. So you can actually feel the rings of Jupiter on the notebook. There you can see 3D images of the Great Red Spot. You can explore all the moons.
Around the Jupiter.
Yep. So, no place in our solar system has more data than the Earth. After that, Mars and Moon are pretty covered. We've only had like one major missions that orbited Jupiter and one to Saturn, so we don't have nearly the kind of coverage that the terrestrial planets do, but we still have a lot of information. And that's the great thing with AR is that we can always update more. As scientists figure out new things, as we process data, we can always add in this extra content and get to know these worlds better. So most of the data on our program, our free AstroReality and AstroReality Earth apps, are on terrestrial planets, but we're always adding more and more for the outer planets. And we always take suggestions. So if people want data, if people want any data, we're able to put that at the top of the queue. So feel free to email us at hello@astroreality.com or hello@astroreality.com. Tell us what information you want to experience in AR, and we can put that to the top of our list to help that for with things you want your students to learn, your kids to learn. We can always add the more data and put that in their experience.
Well, I really appreciate the capability of being able to automatically update data sets. It's not like the textbook that's out of date as soon as it finally reaches the classroom, because our understanding of these have changed and our findings change so rapidly that you just need the object and the app, and whatever's going to be in the app is going to be the latest and greatest and new findings. So that's a excellent feature for I love it too for all this. Okay, so this question's from Ron. Does Neptune have a rocky surface? And we can go out there to Neptune.
We go out to Neptune. Yeah. Neptune is this blue. It does not have a rocky, well, the surface that we see is definitely not rocky. It's made from, again, the gases of the outer solar system, a bit more icy than we have in Jupiter and Saturn. But if you were to go deep into it, there would be a rocky interior. Again, you would have that iron core, the metal core that all the planets have. That's just the densest material in our solar system. So all the planets have some amount of iron in the center. And then the silicate rocky materials would be around that. And then you would have the thicker atmosphere that makes up most of the volume of that world. So there is a rocky surface in there, but you have to go through a lot of gas clouds and atmosphere to get to it.
Okay, we have another question, and this one comes in to us from Craig. Is it true that the moon is moving away from the Earth?
Yes. Yes, it is. So back in the Apollo mission, we put a little reflector on the moon, and we shoot lasers at it all the time. And by calculating how long it takes a laser to go to the moon and back, we can actually see this kind of movement away. The last I heard is it's about 1/4 of an inch per year that is slowly moving away. Because when the moon formed from a giant impact on Earth, and all the material from this kind of collision got thrown into orbit, and a lot of that condensed to be the moon. So we see here, like, these are not to scale. So if this is, so here we see the actual scale of Earth to a very tiny moon. So the moon is just a fraction of the size of Earth, and so every year it gets 1/4 of an inch away. So that's not very much per year, but over millions and millions of years, it can be very significant. One of the cool things I think about living now is that we have these total eclipses, where if you look at the sky, the moon is the same size as the sun sometimes, so we have total solar eclipses. In a few 100 million years, the moon will be so far away from Earth that it won't be able to ever block out the entire disk of the sun. So there will be some day when there will no longer be total eclipses anywhere on Earth ever again. And it's interesting to me that humans happen to live during this period of eclipse possibility.
So how about more thumbs up, more smiles, more hearts? And if there's no more questions, or I'll let Joanne and JR wrap it up.
Yeah, everything that JR introduced and kind of explained, you can learn a lot in AstroReality, and those models and the products that we develop, feel free to explore astroreality.com, but then you can also download the AstroReality's app, which is free on iOS and Android. You can just download it from App Store or Google Play. Go ahead and search that. You can learn a lot in the AstroReality app, and feel free to feedback to us if you have any great ideas. We are always welcome to ideas from everyone.
Yeah, so tell us what you want. We'll try and put that into augmented reality and really make a dynamic system where we can, experience all these faraway worlds in our lives today.
So I'm looking forward to the data layers, which will feature the SETI Institute scientists, like which scientists are working on Mars, and features that, well, Natalie Cabral's rover was here, and Lori Fenton studied these alien features. So I'm looking forward to the specialized content that we can get on the planets. And just remind everybody, we're at SETI.org. Visit us today, visit us tomorrow, visit us often, and let us know how much you love the SETI Institute. And so thank you all, and we'll see you next time.
Thank you.